All right, ladies and gentlemen, so 25, 26, go to page 26, please. Go to page 26. Okay, so we're on page 26. Let's take a look at number 11 and number 12. Now, just looking at 11 and 12, do you feel that these have horizontal asymptotes or not? Yes, they do. They do regardless if I added or subtracted anything from them. But, so as you look, and now the nice thing is when we say, hey, label the domain and range, the domain for all of these is always the same. It's that. Okay? So that should be freebie points on a quiz or a test. Hey, what's the domain? Oh, dude, it's negative, positive, infinity. At least you get that point. Okay? So let's take a look at what this graph looks like. Does it appear we have a horizontal asymptote? Which we do, but what is it? That's my horizontal asymptote. It's 3, right? If I add or subtract anything from it, it's going to be 3. Okay? So that's the imaginary line that we can't cross. Agree? Agreed. All right, so we talked about yesterday, well, if I wanted to find where it crosses the y-axis or the y-intercept, I plug 0 in for the x component. So I get 2 raised to the 0 power, which is 1. 1 added to 3, which is 4. Everyone okay with that? Okay. And then we can find a second point. I can do 1 comma, plug that in. Okay, 2 to the first power is 2. 2 plus 3 is 5. Okay, so 1 comma 5. All right? So this graph looks like this. So is that growth or decay?
Growth.
It's growth. Because as I go to the right, I go away from what? What line? What's it called? Asymptote. As I go to the right, my graph grows away from the asymptote. Okay? I can now do the range. Okay, so as I go forever that way, what line will, or what number will I never get to?
3.
I will never get to 3. Okay? As I go to this way, there's another number I won't get to, but it's really big. Infinity.
And beyond.
And beyond.
Yeah.
Okay? Yes. All right, so let's look at this on the calculator for a minute. Oh, that's pretty from yesterday. I remember that. That was so much fun. All right. So let's plug this in. Too much talking. So I just want to look at this on the calculator real quick. 2 to the x plus 3. If I graph it, it looks like this, which should look similar to our graph. Now, remember yesterday I talked about the table on the calculator? So I have second table, and we should agree that 0, 4, and 1, and 5, those are 2 numbers we have. Agree?
Yeah.
Now, there's a whole lot of other numbers. Now, if I go backwards to the negative numbers, okay? So notice the negative numbers. So look at it. It goes 3.5, 3.25, 3.125, 3.0625, 3.013. Let's go. Oh, look at this. Oh, Mr. Stirrup. Look, it did get to 3. Oh, it did? It did? No, if I go over and see what that really is, the calculator just doesn't want to put 13 decimals on it. Now, here's a little disclaimer on this one. You go here. Nope, that one. Maybe if I go to 5. What happened? Did I really get there? No. We got to the limit of the calculator. The calculator say, dude, I can take you out 13 decimal places. After that, you're on your own. Okay? So don't ever confuse the calculator going, oh, look, it's an asymptote, but look, the calculator says I got there. Okay, thanks. Calculator says I got there, But please realize, as you come back down to a nicer value, so at the negative 44th power, we got, look at that. Look at how many zeros it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 decimal places. Is the 13th decimal place a pretty darn small place?
Yes.
And the calculator has to truncate it off at a certain point. Okay? I guess there's a way that we could modify this on the calculator. We put it in scientific mode so it goes to scientific notation automatically. I guess I could go mode. I could go just scientific. Enter. Second table. So let's go even smaller. See, it says 3e to the 0. 3e to the 0, that's pretty small. Okay, but it recognizes that it's going e to the 0, so you're not really there. Okay, let's get out of this mode. So I'm going to forget I'm in it. It's going to goof up everything. All right. Feel good about number 11? Good. Number 12. Let's take a look at that. Number 12. We got. I have g at x. G at x is the same thing as f at x. F at x is the same thing as?
Y.
Y. Good. Okay. What is my horizontal asymptote on this one? Negative 5. Hey, what's my domain?
Negative infinity to infinity.
Negative infinity, positive infinity, right? Okay, and we'll graph it before we get that. We have an asymptote at negative 5. Does everyone feel comfortable with that? Is that okay? All right, let's figure out where it crosses the y-intercept, or the y-axis. So I'm going to plug 0 in. Bless you. I'm going to plug 0 in. 4 raised to the 0 power is what?
1.
1. 1 times half is?
A half.
Half. Half minus 5 is negative 4.5. Negative 4.5. Is that all right? So it's like here. Agree? Let's figure out my next point. So I'm going to plug 1 in. 4 to the first power is?
4.
4. 4 times half is?
2.
2. 2 minus 5 is?
Negative 3.
Negative 3. Bless you.
Thank you.
Hey, is this growth or decay?
Growth.
It's growth. Why is it growth?
It's going away from the asymptote.
It is going away from the asymptote as I go to the right. All right? Hey, so my range. Let's look at my range. My range, what number will we get really close to but never cross?
Negative 5.
Negative 5. Where am I going?
Infinity.
Infinity. Done.
We did it.
Sweet. Sweet. Okay. Let's look at number 13, and we can actually look at number 13 just as a graph. So we have, we're calling it our parent function, and then this is our modified function to that. Okay, so we have f at x, which is the same thing as y, equals 3 to the x. We have g at x, which is the same thing as f at x, which is the same thing as y. So y equals a times that. Okay, so I think we can do this type of problem just by looking at the y-intercept. So what does the y-intercept appear to be on this very first one? Look at your graph. 1, okay. Okay, and we know that if I took 0 plugged in, 3 to the 0 is 1. Cool. What does my y-intercept appear to be on the second one? Now, if I plug 0 in here, I'm going to get 1 times a. That doesn't really help me. So what does my y-intercept appear to be on this line? Take a look. Half. So take a look at your graph. Do you agree with what we just found? Any part of that that doesn't make sense? Okay, now, I want you to think about this. Just use a little critical thinking. When I plug 0 into the top for 3 to the 0, I got 1. Agreed? If I plug 0 into the bottom, I get 3 to the 0, which is 1, right? What times 1 gives me half? 0.5? Or half? 0 times what? So I'll say it one more time. If I double check this, everyone agrees, when that goes in there, I get 1. Yes? We have an unknown variable here. So we're going to do the exact same thing with plugging 0 into here. And we know that right there becomes 1. So what A is going to represent some number. We know that this is going to be 1, and I get half out. So how do I get half out if I don't know what this is? 3 to the 0 is 1. 1 times what number gives me half? And it was 0.5, or half. So what does my A value have to be? Half. So this is my equation. Is that okay? Does that feel okay? Life good? This is actually called the stretch or compression that takes place to the graph, and that's like a pre-calc term. But we'll get there. The next one is actually a shift. Okay? So going to number 14, we're going to do it the same way. Think about it logically. So they tell us f at x, that means the same thing as y. We have 0.5 to the x. And then g at x means the same thing as f at x, which means the same thing as y. So I have 0.5 raised to the x plus k. So take a look at our graph. The two graphs look the same, but one is shifted up and one is shifted down. So let's think about this. Can I look at my very first graph and agree that my asymptote is y equals 0? Agree? What does it appear to be? My asymptote appear to be on the second one. Look at it. -2. This appears to be -2. So this g at f graph plus negative is the same thing as minus. Right there. Okay? Think about how I did that. Think about what I kind of logically went through. I wanted to find some k value, which is going to represent my asymptote. My asymptote on the first one is 0. Y equals 0. What happens? What has to be the second one when you look at the graph? And it has to be -2. Did I go through that logically enough? Now, Sage can verify this. She was in my last period of class. I called this a shift, and I didn't spell shift right. I forgot to put F in.
You're a bad person.
It's a non-denominational school here that has no reasoning for any religion here, because we're a public school. We can celebrate all religions here, which is awesome.
Are you getting us hyped for Ethnic Fest?
Yeah, I'll be there on Saturday.
I'm going to do the open mic.
I might sing Rhinestone Cowboy. I'm kidding. All right, number 15. We have f at x is equal to 2 to the x, and g at x is equal to 3 times 2 to the x. And they want us to graph, they want us to talk about the domain, and y-intercept, and x range. Okay? I think I can do it.
So, dude, I hope so. You're the teacher there, dork. Yes, I am.
All right, item 1. Do these two graphs have the same asymptote? They sure do. There's nothing after the actual function, 2 to the x plus 0 and 3 times 2 to the x plus 0. So it's the same asymptote. So my asymptote is still, on both cases, will be here. Is that okay? All right. So let's do this one in red. All right. I'm going to plug 0 in. That will find me the y-intercept. 2 to the 0 is 1. Is that okay? All right, and then I'm going to plug 1 in. 2 to the first is 2. Growth or decay? Growth. Because as we go to the right, we go away from the asymptote. Let's do this one in black. All right. 0, comma. So if I plug 0 in, 2 to the 0 is 1. 1 times 3 is? Does my y-intercept, is it different? It has the same asymptote, but is it different? It's like stretched up a little bit, it looks like. All right, and then let's plug 1 in. 2 to the first is? 2. 3 times 2 is? 6. Good. All right, so 1 comma 6. So 1, 2, 3, 4, 5, 6. So we're up here. So the black line looks like it's growing faster. They actually approach the same asymptote. The black line will always be above the red line. Kind of just how it'll always be. Get all done, Sage? Yeah. Perfect. I'll get that graded in the grade book. Thanks for coming in. Have a great day. Huh? All right. Would you please pass forward page 25 and 26 only? 25, 26 only. Would I do what? Okay, I'll get you covered. That's just 25. 27, Jack. Hold on for a minute. You didn't get there yet. 27. Oop. Uh-oh. Is it Angelina? Out of control. Out of control. Next thing, you guys will start shooting, squirrels with pellet guns.
We ever do that?
Pretty good marksman with my pellet gun. The guy next door, on all sides of me, they all have dogs that are all bird dogs. They like squirrels too. So they all bury them in their backyard. All right. No, I'm not shooting dogs. I'm just getting them something to play with. Squirrel.
Bring it.
Dogs are cool. Squirrels?
I would. If he hurt a dog,
I won't hurt a dog.
Good.
I'm just getting the dog a squirrel to play with.
Yes. If he hurts a dog, I will run him on gun. I don't care.
Joe's such a threat.
I'm a doggy.
I like doggies too.
I value my life.
D-O-W. All right, looking at page 27. Shh. Looking at page 27. 1, 2, 3. 1, 2, 3. Is problem number 1 exponential? Yes. Why is that? It has an exponent that is a variable. Good. Problem number 2. Is it an exponential?
Yes.
That was actually a trick.
Wow. Oh, please tell me.
It isn't. Why is that? If I plug 1 in, 1 to the first is 1. If I plug 2 in, 1 to the second is 1 to the third is? No, it's 1. 1 times 1 times 1 is 1. 1 times 1 times 1 times 1 is 1. 1 times. Oh, trick question on number 2. That's a sneaky little thing they threw in there.
So what is it?
Linear. Yeah.
It's just some sort of function. Hey, what about number 3? I have x raised to an exponent. My variable is not the exponent, so no. 3 is a third degree polynomial. It's not a Okay, number 4. My y goes from 3 to 5, or 5 to 2 to -1. That's linear. Number 5, it goes from 24 to 12 to 6 to 3. That's exponential. That's actually a decay. Number 6, if you plug 2 in, you get 1.2 to the second power. So that's 1.2 times 1.2 is 1.44. Number 7, if I plug -2 in, I get 8 to the -2, which is the same thing as 1 over 8 to the second. Bless you. 1 over 8 times 1 over 8 is 1 over 64. 1 over 64 times 1/2 is 1 over 128. Woo!
You said over 128.
Yep. 8, 9, and 10, I'm pretty sure you will know how to do. 11 and 12, I'm sure you could do. 13 and 14, I'm sure you will know to do. And 15, I'm sure you do. So guys and girls, ladies and gentlemen, my friends, if you feel comfortable having all up, 27 and 28 done right now, pass it in. If you want more time for no penalty, turn it in tomorrow. Got it? So if you have yours to turn in, bring it on up, please.
Mr. Stern, I have a question. I'm gonna give you like where to draw a line if it goes like up or down.
So we'll work on that. All right. Right there on that folder that says P, hit 3. All right. So, find the front side of that. There's 3 on one side, 3 on the other. I'm actually going to give you a second sheet that will be the back side. It's a lot more blown up. All right. So, let's go through. So, last semester we talked about linear equations. Linear equations, you could have it as slope-intercept form. You could have it in standard form. Or you could have it in point-slope form. Okay, those are all the types of linear equations you can have. Of course, you could have x equals a number, which is a vertical line. You could have y equals a number, which is a horizontal line. Linear, your slope is m. Okay, we know the slope equation is this. Bless you. Okay, the y-intercept is 0, comma b. The x-intercept is blank, comma 0. So solve that. And then the constant rate. So a linear equation, no matter what 2 points you pick, if you pick 2 points real close to each other, you get the same slope. On a linear equation, if you pick 2 points way far away from each other, you get the same slope. The slope stays the same on linear. Okay? Does that make sense how I said that? So the new stuff we are talking about is exponential. Okay? And the exponential equation looks like this. So you have a y-intercept, which is 0, comma, it's actually 0, comma, 1 times a plus c, but I'm not going to write that. You have growth, decay, depending upon which way it goes. You have growth that looks like this. You have growth that looks like this. You have decay that looks like this. You have decay that looks like this. So growth and decay and decay. The rate changes. Depending upon what 2 points you pick, the rate changes. Okay? And the horizontal asymptote is y is equal to c. Okay? Horizontal line. Right? All information we've discussed over the past few days. Agree? You like? Cool? All right, let me move forward. Can I move forward a slide? Average rate of change. Hey, f of x is the same thing as what?
Why?
So this is the same thing as y2 minus y1 over x2 minus x1, which is the what equation?
Slope.
That's my slope equation. So average rate of change and slope mean the same thing. That's actually something you'll see on ACT and SAT stuff. Hey, what's the average rate of change between these 2 points? You're like, find the slope. That's all it is. Why don't you just say that? Because we like to confuse you. Okay? So the average rate of change is the same equation as slope. Why do we use function at x minus 1 or function at x minus 2? We're just trying to label as y2 and y1. That's all it is. Okay? So let me hand out. I made another copy of the back side. It's larger, so it's easier to work with. Can't do it right now. I'm going to grab a fistful before we leave. All right. So let's get there. So that's the first grid, yes? So it's a linear equation. So if I want to find the function at 1, that means I'm going to go 3 times 1 plus 1, which comes out to 4. Agree? Now, the second one we got to be careful on because it's the easiest one to get confused on. The function at x is equal to this, and then the function at x is equal to this. Is that okay? So that means that I'm going to go negative 5 is equal to 3x plus 1. Because I had this here, and I had this here. So then I could solve it. So I'm going to get 3x equals negative 6, so x is equal to negative 2. I plugged 1 in for x, so 3 times 1 is 3. 3 plus 1 is 4. So if I wanted to fill out the table, I could take negative 1 plugged in. 3 times negative 1 is negative 3. Negative 3 plus 1 is negative 2. If I plug 0 in, 3 times 0 is 0. 0 plus 1 is 1. If I plug 1 in, oh, I already found that one. That's right there. If I plug 2 in, 3 times 2 is 6. Plus 1 is 7. So if I graph this, I'm going to get, let's see, negative 1, negative 2. 0, 1, 0, positive 1 is up here. 1, 4 is up here. 1, 2, 4. 2, 7 is up here. So these 4 points are all on the same line if I drew a straight line appropriately. Right? Agree? What is the slope of this equation? 3 over 1, right? This is going to be my slope right here. Okay? So no matter what, if I found the average rate of change, which means I'm finding the slope between 0 and 1, it's going to give me 3 over 1, which is the same thing as 3. If I do the same thing at 2 different points, guess what? I get the exact same thing. Okay, so the slope on a linear equation stays the same no matter what. No matter what 2 points you pick, as long as they are 2 different points. If you pick the same point, you get a slope that's undefined, actually. Okay, because you get 0 over 0. You go, point's undefined? No, point's defined, but the slope of a point is not defined. Okay, does this make sense so far? You okay? Happy? So let's go to this next one. So find g at 1 that okay? Find g at 0. Ooh, why is it negative 1 and not 1? What's being raised to the 0 power? The 3, not the negative. It's not grouped. Okay? If I wanted to use this table, let's see. If I take negative 1, plug it in here, that gives me negative 1/3. How'd that happen? Well, it was 3 to the negative 1, so I have to flip it. Plug 0 in, I get negative 1. Plug 1 in, I get, plug 2 in, I get negative 9. Okay, this one actually has a asymptote here. Okay, so negative 1, negative thirds, like here. 0, negative 1 is here. 1, negative 3 is here. 2, negative 9 is here. So that's what my exponential function looks like. Is that growth or decay?
Growth.
Growth. Why is that?
It's going away from the asymptote.
As I go to the right, I go away from the asymptote. That's a good call. Okay? So, now they want us to find the average rate of change. The average rate of change is the same thing as saying what? Slope. Okay? So, between 0 and 1. So, let's see. 0, I have 0, negative 1. And at 1, I have negative 3. So, if I find the slope of this, I'm going to get negative 3 minus 1 over 1 minus 0, which is, that's going to be plus 1. That's going to give me negative 2 over 1. That's that slope. But if I find this slope here, I get negative 1 comma negative 1/3. Oh, jerks. And then 0, negative 1. So that's going to give me negative 1 minus 1/3, negative 1/3 over 0 plus 1. So that just is going to give me, that's plus plus. On top, it's going to give me negative 2/3 over 1, which is negative 2/3. Take a look at the slopes. Are they the same? Is negative 2 over 1 the same thing as negative 2 over 3?
Yes. No.
They're different, agree? Negative 2 over 1, negative 2 over 3. Two different slopes. Same graph, so the average rate of change, which is also known as the slope, changes on exponential functions. What is the horizontal asymptote on this? Oh, it's just y equals 0. Okay? Make sense? Happy? We'll take care of that on one different table. So, your homework for tonight. Is, if you did not get page 27 and 28 done, you want an extra day on it, get it done. It's still going to be worth the same, okay? And then I'd like you to do page 29 and 30, please. So, a few things, yeah.
Do we need to do 13 since that would already be on the
Oh, because it might harm you to do it again, huh? Might have it on there twice because you might see it on the quiz this week. Ooh. We have a quiz Friday. I will get your quizzes back to you tomorrow. If you haven't taken it yet, you're going to be that person who sits in the hall while we go over it. That quiz Friday, yeah. Friends are like potatoes. If you eat them, they die. I like that. All right.